The quadratic formula. The quadratic formula is used to find the solution to a quadratic equation when the equation is set equal to 0. This also gives us the x-intercepts of the graph of the quadratic function. The quadratic formula is x equals negative b plus or minus b squared minus 4ac all over 2a. To get the values of a, b, and c, the quadratic equation has to be written in standard form and set equal to 0, so that a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. The quadratic formula can also be written as x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Writing the formula this way helps us see that the first part of the formula, the negative b over 2a, gives us the axis of symmetry. And the second part of the equation, the square root of b squared minus 4ac all over 2a, gives us the distance from the axis of symmetry to each x-intercept. You have to add the distance to the axis of symmetry to get one x-intercept and then subtract it from the axis of symmetry to get the other x-intercept. The part of the equation that's inside the square root sign, which is referred to as the radicand is inside the square root sign, is the discriminant. The discriminant tells us if the graph of the quadratic equation will have 0, 1, or 2 x-intercepts. If b squared minus 4ac is greater than 0, then there will be 2 x-intercepts. If b squared minus 4ac equals 0, then there will be 1 x-intercept. And if b squared minus 4ac is less than 0, there will be 0 x-intercepts. A positive discriminant means that there will be a positive number to add and subtract from the axis of symmetry, creating 2 x-intercepts. A discriminant that equals 0 means that you'll not have a number to add or subtract to the axis of symmetry, so there will only be 1 x-intercept that is on the axis of symmetry. And a negative discriminant means that you will be taking the square root of a negative number. The square root of a negative number is not a real number, which means that the quadratic equation does not have a real number solution and the graph will not cross the x-axis. Alright, let's look at some examples of how to use the quadratic formula to solve for x in a quadratic equation. Alright, for number 1, we're going to solve for x with using the quadratic formula, so we need to write out the quadratic formula to get started. So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And here our a is 3, b is negative 2, and c is negative 5. So let's go ahead and plug everything in. So x equals negative 2 plus or minus the square root of negative 2 squared minus 4 times a times c, all divided by 2a. Alright, so if we start with negative, this is like negative 1 times negative 2, so that would make a positive 2. And then plus or minus, let's go ahead and simplify everything underneath the square root sign. So negative 2 squared is 4, and 4, well, we can do this in 2 steps. So 4, and then that would be 4 times 3 times 5 is 60. Negative and negative would be plus 60. And then down here we'll simplify that to 6. Alright, so now we have x equals 2 plus or minus, that'll be the square root of 64, which would be 8, and we'll divide that by 6. So that would be x equals 2 plus 8 is 10 divided by 6, and x equals 2 minus 8 is negative 6 divided by 6. So that would be x equals 5/3 and x equals negative 1. So those are the x-intercepts of the graph, the solutions to the equation when it's set equal to 0. Next is number 2. So for number 2, a equals 0.2, b equals negative 1.2, and c equals 1.8. Alright, so we have x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And now we just plug everything in. So x equals negative 1.2, so that would just be a positive 1.2 plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Alright, so let's simplify what's underneath the square, inside the square root sign, or radicand. I'll just bring the 1.2 plus or minus. We can do this in 2 steps to make everything easier. Here, negative 1.2 squared is 1.44, and 4 times 0.2 times 1.8 is also 1.44. And 2 times 0.2 is 0.4. Alright, so it looks like we're going to have a 0 in our square root. So the discriminant is equal to 0. So 1.44 minus 1.44, 0. So this is that situation where we don't have anything to add or subtract to our axis of symmetry, so we only actually have one solution here. So 1.2 divided by 0.4 is 3. So the only answer that we have to this problem is that x equals 3. So this equation, if it was graphed, it would look where it's just going to touch the axis of symmetry and come back, and that'll happen where x equals 3. Alright, for question 3, same thing. We have a, b is negative 9, and c is positive 2. So we need our quadratic formula. And now we just plug everything in. 9 is going to be positive here since it started off as negative. And negative 9 squared minus 4 times 2 times 2. Now, one thing that I will point out that you need to make sure you're careful with when you're using your calculator is a lot of people make a mistake right here, not putting the negative 9 in parentheses. So if you don't put the negative 9 in parentheses, your calculator is going to think that you want to just square the 9 and then multiply by the negative 1. But if you put it in parentheses, it'll give you the correct square of negative 9, which is positive 81. So remember, negative times a negative always equals a positive. Alright, so let's go ahead and start simplifying. So 9 squared is 81, and 4 times 2 times 2 is 16. So here we have x equals 9 plus or minus the square root of 65 over 4. Alright, now 65 is not a perfect square, which means it's not going to come out of the square root very nicely. So we can leave our answer just like this, but that, if we're comparing it to a graph, doesn't really help us a whole lot. So we can go ahead also and just approximate this to decimals. So to find out what x is approximately, I'm going to just use my calculator and type this in. So when I use my calculator, I do 9 plus the square root of 65, and I take that answer, divide it by 4, I'm getting 4.2, and I'll round that to 7. And then when I subtract, do 9 minus the square root of 65 divided by 4, I get approximately 0.23. So those would be my x-intercepts. Alright, so now's the time to pause the video and complete the independent practice. Once you've completed the independent practice, then press play to check your answers. And here are the answers to the independent practice.